Okay, so when we get to number 13 here, the problems shift just a little bit. Instead of just being equal to a constant, we've got a variable on the other side. Now, nothing really changes, okay? But here's where most people are going to get thrown off, okay? We still isolate the absolute value like we normally would. Well, in 13, it's already by itself, so we don't have to do anything. So the first case is just like what we've previously been doing, okay? We just drop the absolute value bars and we keep everything the same. Now, for the second case, we have two terms on the right side. It's not just a constant, so when we change the sign, we need to change all the signs on the right side. Now, not all the signs in the problem, but all the signs on the right side. So we're going to set it equal to negative x minus 1. Yes? Okay, sorry, I'm doing notes example number 13. Y'all will do worksheet number 13 here in a minute. Sorry, didn't mean to throw you off there. Okay, my bad. Should have clarified that before we started. Okay, so we just got to solve the equation like we would solve any linear equation like this. We want x on one side, so subtract it from both sides. Add 9. 2x is equal to 10. Just FYI, it's much more likely that we may end up with some fractional answers here. In this case, not. Okay. In the other one, exact same steps, except this time we add x. 4x minus 9 is equal to negative 1. We add 9. 4x is equal to 8. Bless you. Now, hopefully you were checking all your answers in the previous one, okay? But all those always worked out. This is where we really have to check for extraneous solutions. When you've got a variable on the other side from that absolute value equation, this is where those extraneous solutions will probably start coming up. So let's check 5. We've got 15 minus 9, that's 6. Absolute value of 6 is 6. 5 plus 1 is 6. So 5 is good. How about 2? 3 times 2 is 6. 6 minus 9 is negative 3. Absolute value of negative 3 is positive 3. 2 plus 1 is positive 3 as well. So both of these work out. Okay, number 14. We need to isolate that absolute value expression by dividing both sides by 2. So absolute value of h plus 8 is equal to 7h. So our two scenarios, h plus 8 is equal to 7h. H plus 8 is equal to negative 7h. That's very hard to say, just FYI. H plus 8. Try it sometime. It's not easy. All right, subtract h from both sides. 8 equals 6h. Divide by 6. Both of those are divisible by 2, so that reduces to 4 over 3. Subtract h from this one, we get negative 8h. Divide by negative 8, we get negative 1. Can anybody see a problem with either of those two solutions when we plug them back into the original? Any issues with either of those two solutions when we plug them back into the original equation? Yes? Exactly. When we plug negative 1 into the right side, we're going to get absolute value is equal to negative 14. And we're multiplying absolute value by positive 2, so there's no way for that to become a negative. So negative 1 is an extraneous solution. Probably would not hurt to check 4/3 just to make sure. I'm pretty sure it's fine, but you don't want to make a simple mistake by just neglecting to check your answer. So plug in 4/3, 14 times 4/3. Okay, 4/3 is good. But negative 1 is not a part of our solution because it does not work. All right. Let's look at 15. Okay, 15. We've got to get it by itself first, so we have to start by adding that 5 in to the right side. Absolute value 8 minus 2n, 6n plus 2. 2 scenarios. You just drop the absolute value bars, keep everything the same. Second case, change both the signs on the right side. Solve the equations. Plus 2n. Subtract 2. Both are divisible by 2. This time it's 3 over 4. What? Are we having a debate back there? What are we debating? The worksheets?
Yes.
Okay. Oh, so let's see here. Divide by 2, we get negative 5 over 2. Okay, definitely want to check both of these. Now, on the right side, if we do plug in that negative 5/2, we do get a negative, but it might be okay. It might be okay because we've got something else on the left side with the absolute value. So I'm totally going to rely on my calculator on this one. Math over to num, ABS. 8 minus 2 times, I am going to check the 3/4 just to be on the safe side. Close your parentheses. When that absolute value bar ends, you've got to close the parentheses. Minus 5 times 3 over 4. And let's check that versus 3 over 4 plus 2. Hopefully you already knew that. Let's try the negative 5 over 2. Negative insert 5 over 2. Ooh, that one definitely does not work out. Did I type everything in right? 8 minus 2 times negative 5 over 2 minus 5 times negative 5. Yep. Okay. So another extraneous solution. Now, that is not to say that every time you get a negative answer with these absolute value problems that you should throw it out. Because sometimes the negative, and we got negative answers for the problems before this. Okay, but it's much more likely with these absolute value problems with variables on the other side that you will have to throw out one of the solutions. Okay, so you're